Okay, continuing on in section 2.3. So I've got two relations to find. And so example, f of x is negative x squared plus 5x minus 3. Find f of q. So again, I can write down f of x is equal to negative x squared plus 5x minus 3. I need to find f of q. All that means is replace the x with a q. So f of q is negative q squared plus 5q minus 3. So I replace the x with a q. What if I were asked to find, f of 0? So I replace the x with a 0. So minus 0 squared plus 5 times 0 minus 3. So this is 0 minus 3. So f of 0 equal minus 3. On a graph, 0, negative 3 would be on the graph of that particular function. Now that gave us these functions f and g. Now they're asking us to figure out something for g. So g of x is 2x plus 3. I need to find g of a plus 1. So what this means is replace x with a plus 1. So g of x is 2x plus 3. So what you can do, you can do this. You can write g with just parentheses. Okay. So g of anything is 2 times that plus 3. So if I need to figure out what g of a plus 1 is, I just plug in a plus 1 for x. And so g of a plus 1 is equal to 2a plus 2 plus 3. G of a plus 1 equals 2a plus 5. Okay, so all you're doing is wherever you saw an x, you're replacing that with an a plus 1. So look at another example of this. F of x is 3x minus 7. Find f of 3. So f of x is 3x minus 7. That means f of 3 is 3 times 3 minus 7. That's 9 times 7. F of 3 equals 2. Now let's look at this. I've got f defined by this ordered pairs, negative 3, 5, 0, 3, 3, 1, and 6, negative 1. F of 3. When the x value is 3, what is the y value? So I know from right there, f of 3 is 1. Okay. What is f of 6? F of 6 is negative 1. When your x value is 6, you get negative 1. What about f of 7? If I look at my domain, negative 3, 0, 3, and 6, I don't see a value for 7. So this is undefined. I don't have a definition for how to evaluate f at 7. Okay? Looking back at mapping notation, so the domain is on the left, right here. The range is on the right. What is f of 3? If I look here in the domain, when you input 3, you output a 5. So f of 3 equals 5. F of 10 equals 12. F of 0 is undefined. There's no definition for what to do when you plug a 0 in for f in this particular function. Let's look at a graph here. So similar thing. So find f of 3. So here are my x values, here are my y values. So f of 3. What is your y value when f is 3? So here's 3. I come up to here. That is the point 3, 4. That's my x value and my y value. So f of 3 equal 4. F of 0. So f of 0, I don't quite see that one. Let's just assume it's 1. It's hard to tell on this graph. It's not accurate. Let's just say it's right there. So we'll say 0, 1. So you f of 0 means look at the 0x, and what do you get? You get a 1 for y. So that's what you're after, is looking at the xy coordinates for that graph. So again, when we're looking at this function notation, f of x, okay, so we're talking about functions of f defined in terms of x, okay? So if I'm asked to put something in function notation, I'm going to solve it for y and just replace that y with f of x. So let's just say, for example, I want to take this and write it as a function. So y is equal to x squared plus 1. All I have to do is just replace y with f of x. So f of x equal x squared plus 1. That's my function notation. Now, to find f of negative 2, I just replace the x with a negative 2. So this is going to be negative 2 squared plus 1, which is 4 plus 1 is 5. So f of negative 2 equal 5. F of a is going to be equal to a squared plus 1. Just change the x to an a. So you get a squared plus 1. Let's look at the next one, x minus 4y. X minus 4y equal 5. So the first thing I need to do, I need to solve for y. So to solve this for y, I'm going to do, so x minus 4y equal 5. I'm going to add 4y to both sides and subtract 5 from both sides. So I get x minus 5 equal 4y. And now what I need to do is to divide everything by 4. So x minus 5 over 4, that equals y. So this function is f of x equal x minus 5 over 4. Okay? So that is this as a function of f. That is f as a function of x. Okay? So you should have seen this before. We're just trying to make sure you're comfortable with this notation, well, because we'll be using it quite a bit as we go further. I'm going to skip the definition of that and just go straight into what it means for a function to be increasing or decreasing. So this is another property of looking at a graph. So I want you to think about this graph. Think about it. Think about you are riding a roller coaster, okay? And let's just say for mathematical purposes, our roller coasters always go from left to right, okay? So in this particular graph right here, if I'm right here on the roller coaster, okay, so I'm starting here. So it looks like I don't even get on the roller coaster till I get right here, okay? I'm on the roller coaster. Am I going up or down? I am going down, okay? This roller coaster takes me down until I get to here, okay? Once I get to this point, my roller coaster is on a different spot and my roller coaster starts to go up. Once I get to this point, my roller coaster goes steady. It no longer goes up or down, okay? So mathematically, we're talking about the term if a function is increasing or decreasing. So what it means is, let's just say, for example, I mark these two spots. If I go from here to here, okay, if I travel from that first red mark to the second red mark, did I go up or down? You go down, okay, so that is called decreasing. So we can write for this function here, if I travel from, let's just mark it from this point to this point, that's the interval where I am decreasing. So I know that this function is decreasing from that is what, 1, 2, 3, negative 3. So it's decreasing from negative 3. Excuse me, let me back up. Not decreasing from negative 3. This function has an arrow on the end of it. So right here, it's decreasing from negative infinity. So let me back up from what I said previously. So at first I thought of that as an endpoint, but that arrow means it's decreasing from negative infinity all the way to the point 1, okay? Always a parentheses around infinity or negative infinity, and there's a parentheses around that 1 because you see that open circle. So it decreases from negative infinity to 1. Now, where does it increase? It increases, it starts increasing at 1. So it starts increasing at 1. So it starts increasing at 1, and it increases up to the point of 3, including that point, okay? And then it is just constant, neither increasing or decreasing, and that looks like from 3 to infinity, okay? So all these 3 intervals you see me listed here are on the x-axis, okay? So again, travel from left to right. You're always decreasing until you get to 1. That's what this first one means. Then it looks like we increase between 1 and 3. That's this. And then we remain constant from 3 to infinity. That's the next interval that you see there. Okay? And that's just explained in what we see there. Same function. And let's look at an example here to end up our section. So this one shows the relationship between the number of gallons of water, G of T, in a small swimming pool. By looking at this graph, we can answer some questions about the water level in the pool at various times. So for example, at 0, the water is empty. The pool is empty because if you look at the hours, that's my x-axis, and then the number of gallons is my y-axis. At 0 hour, it looks like I've got 0 gallons, so I'm starting with an empty pool, okay? Then they're going to ask me some questions about this particular graph. So if I go further down, what is the maximum number of gallons of water in the pool? So where is this at its highest? So it looks like the highest I ever reach is 3,000. So the maximum value is 3,000, okay? So that's the maximum number of gallons. And when is that maximum level first reached? So it looks like I first reached that, if I look at this graph right here, when I get to 25 hours. So 25 hours is when I reach 3,000 gallons. And then another question, for how long is the water level increasing, decreasing, or constant? So it looks like the water level increases for the first 25 hours, okay? So it increases from 0 to 25 hours. And then what does it do? It looks like it remains constant from 25 to 50. So it's constant between 25 to 50 hours. It also looks like it's constant from 75 to 100, from 75 to 100 hours. And then it looks like it's decreasing between 50 and 75 hours. Okay, so water level increases for the first 25 hours. It's constant between 50 and 75 and between 100 and 75. So that tells me that there are 25 hours of increase. It looks like there are 50 hours of constant, and then there are 25 hours of decrease. And then it says how many gallons are in the water or in the pool after 90 hours. So at 90 hours, it looks like I'm at 2,000, okay, just by reading the graph. And then it says describe a series of events that could explain this. So it looks like you've got an empty pool. You start filling the pool, and then you let it sit for a while, and then you start draining the pool for a certain amount of time, 25 hours, and then you let it sit again. So anyway, that's just an example of using increase or decrease. So hey, that's the end of section 2.3. You have homework in this section as well. So 2.2 and 2.3, you have homework and a quiz, and I will see you guys on Tuesday.